All right, we're going to take a look at graphs of transformations of cubic and quartic parent functions. So a cubic function, let's just write out what the parent function is. Y equals x to the third power is the parent function for your cubic functions. I think that's probably no surprise. Cubed is x to the third power. Remember, the parent function is just x raised to a power without any transformations, no other numbers in here. The parent function for quartic functions is y equals x to the fourth power. So that quartic is a fourth power, cubic is a third power. Okay, so example one, how do transformed graphs compare to the graph of the parent function? So part A, we have a transformed graph, g of x equals 3x to the fourth minus 18. So let's just make sure we are identifying, I can see an x to the fourth in there. So the parent function is y equals x to the fourth. And we want to identify what changes we made to that parent function. If we look at the graph, g of x is the transformed one. I probably should have written f of x right there. F of x is the parent function. So when you look at there we go. When you look at the graph, our f function is this blue one. So this is what a parent function looks like for a quartic function. It kind of looks like a parabola, but it's like, it doesn't have that 1, 3, 5 pattern. It's quite a bit wider. So we can look at the equation and identify the transformations. So our function with g of x equals 3x to the fourth minus 18. So when we're multiplying, the x to the fourth times 3, that is going to be a vertical stretch. It's a vertical stretch if that number is bigger than 1. If that number was between 0 and 1, it would be a vertical compression. What that's going to do to the graph, it's going to narrow it. That's how it looks to us. It gets narrower. This minus 18 off on the end, that is a translation. Are we moving this left or right or up or down? So that's a vertical translation on the end. And we translated it down 18 units. And that's how the transformed graph, g of x, compares to the parent function, f of x. It had a vertical stretch, so it got narrower, and it had a vertical translation, so it moved 18 units down. So what's kind of nice about this lesson is you guys have already learned about your transformations. So we're just applying it to new functions, recognizing what we see, and the structure is all very similar, so it makes it a little easier to answer questions when we're just relying on prior knowledge. Okay, so we have our second example, h of x equals 5 times x minus 2 raised to the third power plus 4. So what is the parent function here? I'll go ahead and just call the parent f of x. I can see here's the x, and here is we're raising it to a third power. So x to the third power is the parent function. If we look at the graph, the f function in blue, this is the parent function for your cubic functions. It goes through the origin, it goes up on the right, down on the left. But we can see that our transformed function, h of x, looks a little bit different. So let's identify those transformations. Our function is h of x equals 5 times x minus 2 cubed plus 4. All right, so we can start with that 5 out front again. Same idea as the last one. We're multiplying the x term by a 5. That is going to be a vertical, either stretch or compression. Because that number is bigger than 1, it's a vertical stretch, which means that your graph will get more narrow. It's going to be more narrow than the parent function. All right, now we have this minus 2 in here with the x. Any Anytime you're adding or subtracting a number from your x value, that is going to be a horizontal translation, which means a horizontal shift. And then what's our little thing to remember the x is? This is a tricky x. It looks like -2 to the left too, but it's tricky. So we're actually going to shift to the right 2 units. And then we've got this +4 on the end. We saw something similar in the last example. That is a vertical translation. And because it's +4, it's gonna translate up 4 units. So if you compare our two functions, the transformed one over here, we can see that this point 0, 0 got moved over to 2, 4. So that means it went to the right 2 units, which we said it did, and it went up, well, it's kind of hard to see with this y-axis, but it did go up 4 units right there. And if you notice, it is a little bit more narrow, the red one versus the blue one. That's because of the vertical stretch we had out front of a 5.